All right, thank you, Prashant, and welcome back, everyone. Throughout today, we've spent hearing from a variety of our stakeholders and industry experts on the various innovative approach, be it technological, be it regulatory policy, that can be considered or are being considered to help address challenges that we are facing due to the continued growth of inverter-based resources, large load, grid transformation, so on. So and this panel intend to continue that discussion further and look towards our neighboring system operators within the United States and pose the question of them, more so from the angle of, more broadly, what are the innovative approaches you are considering? So we have with us a variety of experts from PJM, MISO, California ISO, and New York ISO here with us for the panel. And the question that I have for each one of them is really, what are the innovative approaches you are considering to solve the challenges that you see grid transformation either bringing or may bring to your footprint? So Dr. Emanuel, if I may start with you.
All right, thank you. And I do have slides, but I promise it's only 2-3 slides. My name is Emanuel. I'm the Senior Director of Applied Innovation and Analytics at PJM. Hopefully you're familiar with PJM. We're part of the Eastern Interconnection, the dark blue that you see there in the map. We have peak load, 165 gigawatts, more than 180 gigawatts of installed capacity. We cover 13 states and Washington, D.C., and we serve about 67 million people. As Manu said, we've been trying to use innovation in our old strategy, and I think this is going to be Manu's legacy. Innovation became one of the pillars in our strategy at PJM. So we actually formalized innovation, and we've been doing a lot of innovation competitions. There's a whole process on submitting ideas and problems. So I actually was having a hard time picking topics for today. But in the end, since this is a summit, I decided to keep it very simple. 2 things and 2 things only that keep me awake at night. One keeps me awake because I'm a little bit worried about it. The other one keeps me awake because I'm really excited about it. So one is more like a challenge, the other one is more of an opportunity. If you move to the next slide, please. So if you have not noticed, I do have an accent. I'm originally from Argentina, and a couple of months ago I was visiting and I found that amazing transmission tower robot. And it was really cool. It has lights, it can wink at you, and for the record, you should never trust an Argentinian that winks at you. But I thought it was a brilliant way of trying to address this not in my backyard problem. And here's a challenge. This is what keeps me awake. If I have to encapsulate our industry in one word, it would be uncertainty. I think it's incredible uncertainty that we're facing right now. And you have 2 ways of dealing with uncertainty. One is, let's try to have a better crystal ball. And again, we had panels talking about probabilistic approaches and try to anticipate the challenges even further away. Well, the other approach would be, well, how about we get better reflexes? How about we can react a little bit faster? So to me, the problem is that it's not that we lack the vision. What worries me is that we don't have the ability to respond to the future fast enough so that it matters. And think of permitting, think of interconnection process, think of even gas infrastructure. Even think of the way the vendors can incorporate some of the new software tools that we need, and they need to do it fast enough. So I'm not too worried about coming with innovation. I'm mostly worried about, can we apply the innovation fast enough so that it matters? Don't have an answer for this one, but I wanted to share my worries with you. If you move to the next slide, thank you, this is the one. This is the one that keeps me awake because I'm really excited about it. And of course, it's innovation, so you have to have something on AI. But what really I think is extremely attractive is agentic AI. If you had not heard the word agentic AI, don't worry, it'll be the buzzword for 2025, so you're going to get tired by the end of the year. But in a nutshell, agentic means the AI will have a little bit of autonomy. So it's not a tool anymore, it's more like a team member. It can grab data, it can create its own workflow, it can run simulations, and again, summarize results and present it back to you. So I think it's extremely powerful, but I wanted to share with you a quick example. This is, I want to say 3 years ago. We had this massive storm rolling through our system. And as you know, we designed the grid for N-1. We were operating at N-16 on a very tight spot of our network. Long story short, we had to shed load to mitigate the risk of cascading outages, just like what happened in Spain. Now, the load shedding, it was very difficult to figure out how much load to shed and where to shed. The system was in pieces, so when the operators were trying to solve one problem over here, some other problem popped over there, and it kept moving around. In the end, we shed like 500 megawatts. They did a good job, but it was suboptimal, and again, they didn't 100% mitigate the risk. So we took that problem offline, and it took me and my team, I want to say 2 months, to come up with a solution, code it, run all the simulations to prove it. And in the end, I think it's an elegant solution. It was a marriage between optimization and machine learning. So it's a complicated problem. We wrote a paper on it. But now, picture this. Imagine having an agent AI, that on the fly, during the event, can grab the data, run simulations, come up with a workflow, and hopefully it'll come up with the same solution that I did. But if it comes with something better, then I'm totally going to take credit, and I guess I'll publish another paper on it. But I think this is the key. The agent has autonomy. I think it can take us from just dashboards and automation, which is what we've been doing in the control room forever, to situational intelligence. This is beyond situational awareness. This is situational intelligence. And just the last quick remark here, because my operators asked me the same question. Are you trying to replace us? And the answer is no. Human brain has 2 hemispheres. Left hemisphere is more analytical, logical. Right hemisphere is more creative, more intuitive. All we're doing is adding a 3rd hemisphere. Yes, it has more memory. Yes, it can do calculations really fast. But each hemisphere has its own weaknesses and strengths. Together, I think they're going to make better decisions. So yeah, there's a whole world of possibilities with agentic AI. So that's the one that keeps me excited. I'm going to pause there, and I look forward to the questions for the panel.
Thank you, Dr. Emanuel. Very insightful. With those thoughts, I will invite now the Congcong Wang from MISO to come share what you've been up to at MISO.
All right, thank you. Good afternoon, everyone. I'm very glad to be here to share our markets and grid innovations as we all manage the fast changing energy landscape. So let's first kind of overview our research portfolio, and then we'll look at a couple of the innovations here. So on the left, on market portfolio, we look innovative solution to enhance our market products, including dynamic reserve, which is to procure adequate reserve when it's needed, and also locational reserve to ensure reserves can be delivered where needed. And we also look to the need of new market products. Also, we look to optimize how we commit and dispatch resource in the changing resource mix, especially with the solar-driven net ramp, as we are looking at our solar, really trying to match the wind exceeding 30 gig by end of next year. So storage, the optimal usage of storage will be a key to manage the system volatility. So on the right-hand side, that's our grid portfolio. So as we see larger share of the inverter-based resources serving the load, how do we have the right visibility of stability risks, and how can we effectively maintain the voltage and the frequency stability? And we are also working with our research partners to look at the grid forming services. Large load, talk a lot today about large load. It's a collaborative effort between planning and operating horizon, not only to make sure we have enough resource and transmission to serve this rapid load growth, but also in the operating horizon, how do we monitor, detect, and mitigate those large load swings. Also, Do want to say, like, very encouraging to hear this morning's panel, all looking at the similar challenges. There's a lot of industry collaboration approach here. And we are also working closely with our members and research partners to really integrate the transmission technology innovations. And for both portfolios, we have multiple use cases under our Operation of the Future and market redefinition to look at using analytical innovations, really utilize AI in the energy sector to manage uncertainties, manage congestion, and enhance the control room of the future capabilities. So now let's look at our first innovation, dynamic reserve. The energy transition is really driving a new risk profile and challenge the traditional static way we set reserve requirements. As you can see, the uncertainty is largely increasing by multiple fold. Also, the uncertainty coming from all sources, not only the traditional forecast errors, but even generation and fuel during extreme weather and imports, exports. And as you can see, the uncertainty profile varies throughout the day. So carrying 40 gig of reserve is the easy answer, but extremely costly. So how do we quantify the net uncertainty and capture the volatile profile? And how do we set reserve requirements, balancing reliability and market efficiency? So MISO's dynamic reserve initiative is really to set the reserve requirements dynamically based on the predicted daily or hourly risk profile. So we have operationalized dynamic short-term reserve beginning of last year, and we are actively working on dynamic regulation and the ramp capability product. There are three key building blocks of this initiative. First, quantify net uncertainties that are constituted from not only the traditional load, wind, solar forecast errors, but also all inclusive of the thermal fuel uncertainties and imports, exports. And then we have a machine learning model to predict the uncertainty level, whether it's high, medium, low, based on what has been experienced during the historical likely system and the weather conditions. And from there, for different uncertainty level, we optimize the risk coverage or the appetite to balance the cost we spend to procure the reserve and the benefit when uncertainty materialize. So this net uncertainty model really successfully flagged the high uncertainty in the recent winter storms, and that allows us to pre-position through markets, and along with other uncertainty management efforts in the recent winter storm, we were able to reliably manage the winter storm without going to any emergency procedures, and we were able to control the out-of-market uplift payment down to single digit of the $1 million, as compared to almost like 20 to 50 million outlets in the previous winter storms. It's quite powerful. Next, innovation. Like many other sectors, MISO is also actively looking at utilizing the machine learning and AI models in the energy sector. Actually, machine learning model is not that new to this industry. The RTOs and its vendors have a long history utilizing some of the neural net to predict load, wind, and solar. But the latest machine learning model really created new space for us to do better forecasting the things that we traditionally forecast, such as a reinforcement learning model we developed to dynamically switching to the better performing vendor. And we see very promising improvement in the forecasting by using the better of multiple vendors that has been historically more used for business continuity purpose. The machine learning and the AI also allow us to forecast historically unknowns, such as outage, NSI, even more importantly, the congestion, to allow proactive congestion management as we see more complex and dynamic congestion patterns. So the use of large language model to support the grid operations is another use case that I'd like to spend a little bit more time here. So a couple of years ago, we had a meeting with NASA, and as the conversation goes, a couple of common themes immediately stand up: the simulator training and the operator logging. But there are large volume of operator logins. Who is going to digest all those information and translate into insights to support operation decisions and to support operator training, which otherwise, especially for extreme weather, might take an operator multiple years to gain that experience. So that's where we utilize large language model and build a digital assistant we call L. So I'm going to do a simplified demo of L and its interaction with one of our most experienced reliability coordinator operators. So showing here is the web browser-based interface. On the left-hand side, you can give the personas of the user, and on the right-hand side, that's how you interact. So we work with our most experienced operator, Toby, to test this digital assistant L. So Toby come up with a typical question on the desk. There's this element tripped. And then the L, who has been trained by hundreds of operating guides and procedures, were able to give the right answer, including stability, redispatch, coordination, and mitigation schemes. And that was very good response according to Toby. So he was able to ask the next click follow-up questions such as, what should our units be directed to? Or even cross-check, is there any coordination I need to make? And Al was able to impress our operators with the right answer. And we look forward to more interaction as we go through the testing phase. All right, we're going to pass to our colleague here and look forward to the discussion.
Thank you very much, Congcong. That was very insightful. Sergio, if you may take over and help us understand what California ISO is doing in this space.
Yes, thank you. Thank you very much. And thank you for the invitation. It's great to be here and be able to listen to the lessons learned in different geographies, learn from you all, and hopefully also be able to share some of our work at the California ISO. So I wanted to highlight 4 examples of innovation at California ISO. 2 of them are probably going to resonate with the majority of the audience because they're really about the hot topics of the industry right now. The other 2 are probably a little bit more California specific, but hopefully you have fun listening to them and you can, tell your loved ones, oh, I learned something about this random thing today. So the first one is about AI. I think everyone is thinking about AI. Everyone is thinking about its implications on load and generation, but also what it means for their day-to-day work. At the California ISO, we're starting our efforts to basically incorporate AI into our internal processes and our day-to-day work. We see a lot of potential benefits with, as Emanuel said, integrating a new colleague in a way with AI, from cost efficiency for our data and storage management to accessibility of information. No need to have to ping 2 or 3 people to get the right data to do a simple graph. You can just ask away and get it immediately. And ultimately to enhance our decision making and accelerate the innovation of what we're doing at the ISO. I think a number of use cases that we've identified that we want to work on in the near term boil down to timely response to inquiries from our customers. It would greatly help the folks in stakeholder engagement, customer relations, to be able to quickly ask in a prompted way to help us respond to tickets, and also it would help us to be able to comply with significant requirements, for example, from FERC 760, and have a new colleague that we can rely on. We're also thinking about the use of AI for the accelerating our timelines for resolving issues related to investigations and disputes, right? Usually this involves a lot of different teams within the ISO. You need to talk to folks in settlements, in ops, et cetera, and this will probably allow us to be much more efficient in doing so. So what are the steps we're taking? We've already started working with a price anomaly detection system that is already in flight, and we're learning a lot from it. And we are, starting conversations with vendors and actually with ERCOT to be able to collaborate a bit more into developing common tools and best practices so that we can learn from each other's experience. So the second topic that I think is common across the industry is interconnection. Everyone is facing the challenges of the backlogs, and we've done quite a lot of work in the last couple of years to innovate our process to make sure that it's responsive to the new reality of interconnection. So the first piece that we've worked on has been in kind of revamping our screening process so that we can focus on requests in areas where there is existing or planned transmission. That doesn't mean that open access is being forgotten. You can interconnection customers can still seek interconnection in areas that do not have existing or planned headroom, but they will have a different path. We call it the merchant path, where they will need to fund the necessary upgrades directly. We've also created new scoring criteria that is based on need, is based also on viability of the resources, and on commercial interest. And this last piece, I want to underscore that a key part of innovation in that process has been taken into account the perspective of load-serving entities in a non-binding way, so that way we can get a better sense of commercial interest. These modifications to our interconnection process, they're still ongoing. It's really a job that will keep being a staple of our stakeholder process moving forward. Now we're focusing much more so on not just reforms for future clusters, but within existing clusters that have a lot of requests, how do we prioritize? And we're taking a look at deliverability particularly so that we can focus on resources, that will contribute to our resource adequacy needs. And just to give you a sense of what this has meant, we started this latest cluster with 541 requests over 340 gigawatts. After all of these reforms kicked in, we managed to bring that down to 117 requests and 96 gigawatts. So that's a reduction of about 70% in terms of just the capacity. Last two things that I wanted to share, a little bit more California specific, is innovation in governance. That's a big one. Some of you might be familiar with the effort that we're taking at the ISO to expand regionalization of Western markets. And it's always been a bit of a difficult dynamic, the fact that the California ISO board is appointed by the California government. That has created concern about regionalization, both inside California, people fearing we're going to lose our ability to determine our own policy, but also outside, people fearing that California will impose their policy or something like that. So now, there's a new initiative, Pathways Initiative, you might have heard of it, and we've made great strides in there. Steps 1 and 2 were approved last year that basically call for the creation of a new regional organization that will have sole authority over the Western energy imbalance market and the extended day-ahead markets. But this will require legislative change. And we've been in this boat before with other pieces of legislation, but now I think we're really turning the corner here, because with this new bill, Senate Bill 540, it is clear that we're going to have a distinction between the BA activities, the balancing area activities, balancing authority area activities, and the market, and California will retain its ability to plan, procure, and set its own policy, while the regional organization will have the sole authority over market rules and dynamics, with the ISO then serving as the BA and a vendor to this regional organization. This is great because now we have the support of a lot of people that before were concerned about regionalization. So hopefully September of this year we'll have that passed and be closer to a regional market. And the final one is about storage, which is really where I work on. I'm the storage sector manager in the market policy design team. And in the ISO territory, we used to have like 500 megawatts 2020 of storage. Now we're over 11,000. That's a massive increase in 5 years, over 20-fold. So now we're really getting to a point where we need to model some characteristics that before were not as necessary. A key thing really that comes up for us constantly is nonlinearity of battery performance at high and low states of charge. So we're working on how to better reflect and incorporate nonlinearity. I think in the near term, this usually means leveraging some of our existing systems like outage management. But moving forward, we would want to incorporate that even within our bidding paradigm. Today, storage is bidding in terms of megawatts, but what it's really selling its state of charge. So we'd want to evolve our bidding of storage so that we can better reflect what it's selling to the market. I'll leave it there. I know that was a lot, but thank you for the time, and looking forward to questions.
Thank you very much, Sergio. This was very, very insightful into the variety of things that California is doing. With that, Ms. Laura, if I may call you on to share what are the things that NYISO is seeing and is considering to do.
Thank you. This is Laura Popa. I am coming from New York. Thank you for inviting me here, and congratulations for sticking around for the last panel and the last panelist. So I'm trying to make it funner. My plan for today is to take you on a journey, on a time journey, sprinkled with a little bit of innovation and a little bit of fun. So we'll see, and all in 7 to 10 minutes. So don't worry, if I go back to 1900s, I will not stay there for long. So New York ISO, I've been with the NYISO for over 20 years, all in planning, 1/3 transmission planning, 1/3 interconnections, 1/3 resource planning, which is what I do right now. I was supposed to be in the other panel, actually, on the probabilistic assessments. Interconnection, your stories reminded me of back in 2005 when we had to figure out renewable portfolio standards and new FERC tariffs and how to implement them, and the wind rush. We started with wind, so it started back then in 2005, right? And now we are talking about new reforms, Order 2023 cluster. We have been implementing our cluster before we got the FERC approval, and we got the FERC approval the other day, and we are very, very happy to see that they accepted most of our filings. So NYISO is a whole, we administer, it's a single state wholesale market administrator, grid operator, planner, I'm from planning, technology, we do everything through technology, very important. And also we are an authoritative, and I knew I could not pronounce that word, I should have used another word, an independent source of information. We also perform studies. To perform studies, we model. We use very complex models. We make assumptions for 10 years from now, right? We don't have a crystal ball. So how are these assumptions looking like for our systems, right? But let me go back to the future, or maybe back to the past, 1900s, as I promised. I was researching New York and innovation. 1900s, Edison, Westinghouse, Tesla, all in New York doing great things. And I think you've all heard of them. And then I found Maria Telkes, not from New York, from Massachusetts, and she was called the Sun Queen back in 1940s. So what happened, the first commercial generation was implemented by Edison back in 1900s, very, very early 1900s, if not late 1800s. In Manhattan, the Pearl Street in Manhattan, 600 kilowatt. Now we are serving CanEdison, which is the utility created by Edison. They are serving about 12,000 megawatt of load. So back to the future. Tesla and Westinghouse, they developed the first hydro plant at Niagara. We have Niagara Falls. We are very lucky in New York to have Niagara Falls. Now Niagara hydro plant produces about 2,000 megawatt. Back then it was very, very small, but it was the first one implemented there. So Tesla also, I don't think he was a human, by the way, Tesla. I think he came from a different planet or something. He was working on wireless tower, and he did build a wireless tower in Long Island, which didn't go far away because JP Morgan at the time didn't see a way to make money out of something that you cannot touch, a cable or, So it kind of was left there. But imagine the vision, and that's why I wanted to title my speech here, Back to the Future, Catching Up with the Past. Because wireless, it's implemented in cell phones and everywhere else, but not yet in our world. Imagine that world. So now Maria is a Hungarian-born, I'm from Romania, Hungarian-born American. She was an MIT professor back in 1940s, and she had a vision. She had a vision to harness the power of sun. Imagine that. We are continuing to have that vision today. And she built the first modern house heated with solar power. And also she was working on storing the sun power in a storing device, heating storing device back then in 1940s. There is a documentary about her, by the way, if you want to check that out. The Sun Queen, I believe on PBS. So I think I'll go back to today from there, as I promised. I'll not stay for long there, back in 1800s, 1900s. Today, another fun fact. Electrical vehicles, right, is the subject of the day. I Googled, I hope it's not, it's a fact. I hope it's a fact. I Googled, we had about 40% electrical vehicles back in 1900s. I hope it's a true fact. I didn't double check it. But imagine that, 40% electrical vehicles back then. And then the gasoline took over. So back to the future, right? So today, New York system today, we deal with the bulk power system, high voltage. We don't own assets. We are the planner of the bulk power system. We work very closely with our transmission owners. Their number increases due to the public policy transmission planning projects. We serve at the wholesale level about 30,000 megawatt demand. And we have around 24 IRM, install reliability margin requirement. And we've been in a transition for some time now. We are not at the beginning of the transition. What also happened in an innovative and drove all these changes dramatically back in 2019. So see, I am in 2019 right now. This is good. We will finish today. Back in 2019, New York enshrined in a law an acronym, CLCPA. We had to memorize this acronym. It was difficult. Climate Leadership and Community Protection Act, CLCPA. Very, very interesting scoping document resulted from cross-departments, cross-industry collaboration. And the CLCPA vision is to decarbonize the system, to decrease the greenhouse gases. And one chart stayed with me, and in that chart, the energy sector was just a little bit of a slice. A bigger slice was buildings, as big as the buildings was transportation. So in order to decarbonize New York, one has to think holistically through all of these things. And when you electrify your buildings, that becomes a load for us, a demand. So we have to take into account for that. So that brings me to the first component, demand. One thing that we had a challenge with for our models was how do we account, how do we project ahead all these targets coming from the CLCPA, which is a law. Not an easy thing, but we've been doing it. We've been forecasting electrical vehicles in our demand forecast for our models. We've been forecasting codes and standards. We've been forecasting BTM solar. We've been forecasting electrification. And energy storage impact at peak, summer, winter. And the newest forecasting that we had to think through is the large loads. We've been getting them, as all of you. So how do you account for them? If you don't forecast them, you don't have them in your model, you don't learn of their impact. You don't account for their impacts. It's very, very, very important to forecast their impacts 10 years from now. I'm coming from 10 years from now, back to the future. So that is innovation, the fact that we've been thinking ahead and forecasting all these components in our demand. That's why we no longer call it load forecast. We call it demand forecast because it embeds all these components. Some of them have a reduction impact, some of them have a positive large loads, electrification going up. So that's on the demand side. On the transmission side, right, our public policy, transmission planning was a main driver for building up our highways, 345 kV highways, starting with Western New York. We have that in place right now. The mid-New York toward New York City, that's completed with a little bit of things left around. The Long Island public policy had the goal to increase offshore wind, and not only to bring it to Long Island, but also to bring it upstate, which is reversing our hundreds of years of thinking that the power flows north to south and west to east. Now we are trying to maybe flow it back. So that's interesting, right? We are in the middle of another public policy right now process. On the resources side, right, we have no coal plants left. We are looking at emission reductions around New York City and big centers like that. We do still have nuclear plants while we did retire Indian Point 2, which was a bit too close to New York City. But we have about 3,000 left. Fun fact, another fun fact for New York, the smallest operating nuclear plant, the oldest, is Guinea. It's 600 megawatt and still operates there. Now we are talking about SMRs, right? Those will be even smaller, 250, 300 megawatt. People are piloting them. We have, and because of everything that's happening, wind, solar, they are, you know, what do we do when the wind doesn't blow, the sun doesn't shine? There is a German word that I wanted to pronounce, I'm not sure, Dunkelflaute, right? Very, I really wanted to say it once. When there is the dark lull, when the sun doesn't shine, the wind doesn't blow, what do you do? So New York, we are a source of information. We came up with an acronym. The acronym is DFIRS. We need DFIRS. You know, how do you replace the attributes that your thermal fossil plants are bringing to the system? How do you replace them? Well, with DFIRS, right? And what are DFIRS? Are dispatchable emissions-free resources, DFIRS, because they have to be emissions-free. We have a goal by 2040 to be 100% emissions-free, and it's not a net. So we need DFIRS. They need to have attributes, attributes such as fast starting, dispatchable, fast ramping, voltage control, frequency control, inertia, you know, it could be anything. We are learning about Spain, we'll see what comes out from there, but DFIRS are very important, and their attributes are very important to be articulated, which we've been doing lately. And I will end here. I know I'm out of time, but I will leave you with DFIRS. DFIRS, you need to come with the technology. DFIRS can be different. They can be a combination of technologies. It doesn't have to be one thing. SMRs can be DFIRS. Batteries can be DFIRS. Grid-forming inverters can be DFIRS. And I leave it there. Thank you.
Thank you, Laura. It was quite a journey, all the way from Nikola Tesla Back to the future, to the current. It's very informative and insightful to hear what all things you have had to consider as you're planning for the future. Thank you for that. So with that, what I'll do is we have a slew of questions. We'll jump to those, see how many of those we can take and cover at this time. So the first one here is for MISO. How does MISO decide the level of risk tolerance to ultimately select the desired level of probabilistic reserve margin requirements? Congcong.
That's a great question. So in the nutshell, the risk threshold is determined by balancing the cost incurred to procure reserve versus the benefit when the uncertainty materializes. And how it translates is varied by product. For example, we are working on the dynamic regulation requirement. And for regulation, it balances between the cost of procure regulation versus the reliability benefit, which we work closely with our business partners based on the reliability metrics to assess the reliability benefit. And for ramp capability product, which is a product to pre-position, pre-ramping the resource. So we can assess not only the cost of procurement, but also the least cost optimization. So what we are doing is setting up a two-tier optimization platform. The outside tier is to optimize the risk level. So you can have different level of choices of your reserve. And the inner tier is giving the risk level you are covering, and also for different materialization of the uncertainty, you run the least cost optimization across your market process to assess the cost there. And then coming back to the outside tier to select the risk level, then strikes the best balance.
Thank you very much for that. Maybe keep the mic close to you, see if you have an insight for us. The next question is, what type of Gen AI do the different ISOs use? Are you considering Claude, ChatGPT, or do you have something else? Dr. Emanuel,
Yes,
you want to take?
All of the above.
All of the above, all right. Any insights from you?
I would say there's no one Gen AI model that the ISO is settled upon. It's really our data scientists. It's problem-driven and also the performance-driven. Our data scientists usually try multiple kind of machine learning models or AI models based on the problem, and then select the model or customize the model based on the best performing model. And we do have kind of data science try to set the performance metrics to measure those.
Yeah, I would say for us, the instruction, let's say for just all employees in their own desktops, if they want some help, is just use Microsoft Copilot. We do that because it's a closed system. It will not inform the training of the model beyond our system. And similarly, we are working with Microsoft on auditing our data practices and the use cases we're interested in.
Laura, do you want to take a stab at it also?
I know there are pilots at the NYISO for things that we already use. It's not necessarily generative AI, but to use the cloud. We are in the cloud with our simulations. Our simulations take a very, very long time, so we had to go to the cloud. We use AWS for that. And I think that's an example of trying other things.
Very insightful. All right, I'll read the next question out. It seems to be, again, related to the agentic AI deployment in the control room. And the question says, to what extent or in what cases are the improvements that were mentioned truly about AI versus being about cleaning, systemization of data? And I think, Sergio, this may be referring to the example you had given around graphs.
Well, I just wanted to chime in quickly here because I love that this question cuts through the buzzwords of AI. Yeah, a lot of this is just about making sure that all our systems talk to each other and are interconnected, and we have good, accessible data to be able to, get information quickly. Is that necessarily generative? Sometimes it isn't. Does it sound way better always to say it's AI? Yes, ask the shareholders of these companies too. Yeah.
Thank you so much. Do you want to take a stab at it?
Just a slightly alternative point of view there. So yes, cleaning the data is a precondition. You won't be able to do anything without you having cleaning data and all that. Granted. But agentic AI is a little bit different. In the example I was trying to give, The AI needs to figure out, oh man, there are multiple constraints. I probably need to run an optimization. Oh yeah, I need to write this in set of equations. Let me write the code, let me run the code, let me take the solution. But PJM doesn't control the feeders. So an optimization gives you a solution. Oh, I'm gonna have to come up with a clever way of giving you more flexibility and more alternatives. That's way beyond doing a graph. And doing all of that, being able to run the simulations, get all the data, and prove that it actually works, that's the power of agentic AI. In the meantime, this is not wrong. I mean, if you're coding by hand without an agent, what are you doing? You should be using AI today. And again, if it simplifies your life to make a plot, great for you, or write an email. But those are kind of like day-to-day things. Agentic AI, I think, has an extra level of power and novelty that I think can change the industry.
Very well said. Maybe we'll leave it exactly at that. If you all could join me in thanking this panel for traveling all the way across the ponds and come to visit us here to share your experience. We really, really appreciate having you here. If you all wouldn't mind joining me and giving them a big hand.